Hello viewers, welcome to UNC Digital class. In today's class, I am going to discuss about insertion procedure in double linked list. As we have already discussed about double linked list, that means how we can create the number of node in double linked list and the traversing procedure for double linked list. As per our discussion, we know that in double linked list, a node contains three parts, that is one info part, one info part and two address part. One address is for forward traversing and one address for backward traversing. That means there is a next pointer as well as a pre pointer. By using next pointer, we will traverse the double linked list node in forward direction, and by using pre pointer or previous pointer, we will traverse the double linked list nodes in backward direction. Okay. So, as it has three parts in a node, so let us see what is the structure of double linked list, and then we will be discuss the insertion procedure. So, this is the structure of the double linked list. Let us consider, suppose struct node, one info part and struct node type 2 pointer which will hold the address of the node, that is pre pointer and next pointer. Pre pointer used to hold the previous node address and the next pointer used to hold the next node address. Then end of the structure declaration block. Okay. So, whenever we declare this, it means the node contain three part, that is one info part and two address part. One is your next and one is your pre. So, this is the structure of the node in double linked list. We peoples are going to discuss about the insertion procedure in double linked list. So, as per the single linked list, we insert a node in double linked list in three locations of the list. That means at the beginning of the list, at any position of the list and at the end of the list. That means insertion procedure in double linked list. So, insertion means we will be insert a new node at a given position of the double linked list. So, insert a new node at a given position. Okay, and we can insert the node in three different locations of the double linked list, that is at the beginning of the list, at the end of the list, at any position. Okay. So, these are the three locations where we can insert the node in double linked list. So, at the beginning of the list means, let us consider this is our double linked list. Okay. Suppose we have three nodes in that double linked list. Those are created 100, 200 and 300 location corresponding and containing data 15, 25 and 35. Okay. As it is double linked list, so the 200 will point to this node, 300 will point to this node and the last node next part will not, because we have last node of the double linked list next part contain null value, because after that we have no node to visit. Similarly, for backward traversing, the last node pre part contain 200 and this node previous node contain 100 and the first node of the double linked list previous part contain null, because before that we do not have any node to visit. So, this is the structure. So, come to this point, if we want to insert a node at the beginning of the list, that means we will be insert the node at this location. Okay. So, we must need the first node address of the double linked list and we will be insert node at the beginning of the list. Beginning of the list means the new node became the starting node of the list. Okay. Then what we will be do in that case, suppose this containing data 26. Okay. And we will only store the address of this node at the next part of this. Okay. That means when we store 100 in this location, 100 is our starting node. Okay. And when you store the 100 at the next part of the new node, then it will point to this node and this node became our starting node. Okay. And after that we will see the node, the new node which will be inserted as the first node. So, we must declare the statement for declaring the new node as the first node. Okay. So, this is the concept about inserting a node at the beginning of the double linked list. Okay. Let us consider we want to insert the node at the end of the double linked list. Okay. Let us see how can we execute it. The end of the double linked list means we will be insert the node at this location. Okay. Suppose this will contain 26 and initially these nodes are containing null value. When we want to insert the node at the end of the double linked list, suppose this is our double linked list which is created at this location, suppose 400. Okay. We will be store 400 at the next part of the last node. Okay. That means at this location if we store 400, then it will point to this. Okay. As it is the double linked list, so as for the forward traversing as well as we have to traverse backward the list. So, for backward traversing we will be store last node address. That means now our last node is 300. The last node address at the previous part of the new node. So, here we will be store 300. When you store 300, so this node will point to this location. Okay. Then after we will be declare as this node as last node. So, this is about the last node insertion in double linked list. Next we will be see at any given position. That means suppose in a list we have number of nodes. Suppose we want to insert the node at position 2, 3, 1 or whatever, you must put the value of the position. That means according to the given position we will be insert the node at the particular position. Okay. So, comes to the third case, we will be insert the node at any position. Okay. So, for inserting a node at any position, let us see how it will be executed. So, this is our initial node. Okay. Suppose the position is given as 2. That means consider this is node 1 and position 2 means at this location. That means I will be insert the node, new node at this location. Suppose the node is containing info 26 and initially pre and next are null. And when I want to insert this node, first I will be move from beginning of the list to the position of the list. Then after the insertion can be done. Okay. So, when I reach at the position, then what we will be do? We will be store. That means we first remove this link. Okay. That means this link must point to this location. Okay. Suppose this is created at 400 location. When this is created 400 location, so this is our position 1 node, this is our position 2. That means this node will be first visit, then after this node will be visit. So, for that we will be store 400 at this location. So, the link will point to this location. Okay. And after that this node will be visit. That means we will be store in this location 200, so that this node is pointed to this location. So, this is about forward traversing after insertion of node at any position. But in double linked list we must have backward traversing. So, for backward traversing we will be stored at this location 400, so that this will be point to this location, and we will be store 100 at this location, so that this will be point to this location. So, in this way we can traverse the double linked list node by inserting the node at any position in forward and backward traversing mode. Okay. So, next we will be see the algorithm implementation for double linked list. That means we will be write the algorithm for inserting node at first position, inserting node at the end of the double linked list, and inserting node at any position of the double linked list. Let us see the algorithm. Algorithm for implementing insertion operation in double linked list. So, as we have insert the node in the 3 position, that means at the beginning, okay, at any position, that we already discussed about it. Then last one is at the end. Okay. So, first our case 1 will be insert the node at the beginning, okay. So, when we go for the algorithm, we must have the address of the starting node. Okay. Suppose let us consider there is a start pointer which hold the address of the starting node. Okay. So, there is a start pointer start pointer is used to hold the address of the starting node. Okay, it means what? Initially start is null, and when the list is created it becomes 100. You can see the starting node address is 100, so it will be assigned to the pointer start. Okay, so then we will start our steps for case 1. Step 1. In step 1 we must have a new node which is to be inserted. Okay, in case 1 or case 2 or case 3 we must have a new node which will be inserted at a given position, at the beginning, end or at any position. So create the new node as new. Okay, suppose we created a new node. Let's assume that the pointer new which is hold the new node address. Okay, then we will store at the info part of the new node the data which is to be inputted, and the address part will be null at the beginning. So in step 2, read the value of NO which will be stored at the info part of the new node. So in step 3, set info of new equals to NO. When the node is created, this will be the structure of like this, and suppose this is created at 400 location which will be pointed by the pointer new. That means initially new is null, and when the node is created it becomes 400. Okay, and I have to read the value of NO. In the info part of the new node we must read a value. Suppose that is NO. Okay, suppose NO is 30. Okay, then set info part of new equals to NO means here I store 30 at the info part of the new node. That means the address which is contained by the new pointer at that location, the info part will be filled by 30 value. Okay, then I will be set the next and pre part. Set pre of new as well as next of new as null. Okay, so now our new node is created and we will be insert this node at the beginning of the list. Okay, we have the starting node address which hold by the pointer start. Okay, inserting the new node at the beginning. So the next step is in step 5, say initialize p equals to start. That means we have another pointer p which now contain the starting node address, that is 100. Okay, then comes to step 6. So in this location we will be insert. Suppose this is created at 400 location 30 and initially it contain null. Okay, the next we will store this node address at this location, and at the pre part of the 100 location node contain the address of the new node. So for that I will be write set next of new equals to p. Okay, you can see p contain 100. When I write next of new equals to p, so the next part of new will be set as the value of p, that is 100. When I set this, then this will be pointed to this first node. Okay, then next I will be set the pre part of this node as the new node. So I can write in step 7 set pre of p equals to new. So it becomes 400. So this will be point to this. Okay, and you can see now our starting node is our new node. So set that value. So in step 8 set start equals to new. Okay, that means now the start is 400. So this is our starting node, and after that you can see the new node became the starting node of the double linked list. Then stop the procedure. Then stop. Okay, so this is about insertion of the node at the first position. Next we will see insert the node at the any position of the double linked list. So next we will be insert the node at any position of the double linked list. So as for our beginning insertion, we need the address of the starting pointer, which is held by the start pointer. So it contains 100, and then we must create a new node which will be inserted at any position. So this is about the new node. We will be create the new node, and address is held by the new pointer. Suppose this node is created 400, initially it is null, and suppose it is created at 400 locations. So new will be initialized by 400. The next will be set the info part of the new node by NO, which will be read by the algorithm, and then next will be set the pre and new part of the new node null at the beginning. Okay. So next comes to now we will be insert the node at any position. As we are inserting the node at the any position, so we must have the position value. So for that we will be read the position. So next step, in step 5, read position. Okay. Suppose the position is 2. Okay. Next we will be execute a loop. As per our discussion, we must reach at the position where I want to insert that new node. So for that we will be execute a loop. Now we will start execute the loop. So initially initialize p equals to start. So p equals to 100, and then we will initialize I equals to 1. So I equals to 1, and then repeat step 7 to 10 while I less than position. So I is 1 and position equals to position equals to 2. So this condition is true. As this condition is true, we will be execute step 7 to 10. Okay. Then set q equals to p. So we have another pointer q which will initially null, and when we execute q equals to p, so p value is assigned to q. Then we will set p equals to next step p. So p contain 100, then next step p means at the next part of p it contain 200, so p becomes 200. Then set I equals to I plus 1, so I becomes 2. Okay. Then again we will go for step 7, then check the condition. I less than POS, I equals to 2 and position POS equals to 2. So the condition is false. As this condition is false, then we will exit from this to step 11. So now we will go for step 11. Okay. And when we come to step 11, then we will link the new node. So we will be insert the node at position 2, that means at this location. Our new node is created 400 location containing data 30, and initially the pre and next part is null. So now we link this node with this node and as well as this node. So we will remove this link and connecting with the new node. Okay. So pre part of the new node as well as the next part of the new node. In the pre part of the new node, we will be stored the address of this node. That means 100 will be stored at this location and 200 will be stored at this location. So now we will link the new node with its previous nodes as well as its next node. Okay. So at the previous node, so we will be stored 100 at this location and 200 at this thing. For forward traversing, we will be stored 400 at this location, because if we store 200 at this location, that means we will remove this link. Okay. So we will be remove this link and we will link this node with this node. Okay. So for linking this node, we will be store 400, that means the new node address at this location, and then it will be stored the next node address, that means 200 will be stored at this location, then it will link to this node. Okay. So in step 8, set the next of new as next of new will be stored 200. So 200 is contained by P. Okay. So when I store 200 at this location, so it will point to this node. Okay. Then we must remove this link. Okay, because this is the forward traversing. So in this location we will be stored the 400, which will be the new node address. So set the next of Q equals to new. Okay, that means at the 100 location next part I will be stored new, that means 400. So this link is removed and this will point to this. So this is about your forward traversing. That means we will start traversing this location. At the next part 400, then we traverse this node. At the next part 200, then we traverse this node and proceed. Next we will link the node for backward traversing. So for that we will remove this link. Okay, that means at this location we will be stored 400 and at the previous part of the 400 we will be stored 100. Okay, so 100 is contained by Q and 400 is contained by new. So just set the values. Step 13. Okay, so 200 is contained by P. You can write set pre part of P equals to new. So this will contain as 400. So this link is removed and point to this node. Then next we will point this node to this for backward traversing. That means at the pre part of the new node will be stored 100. Then in step 14 set pre of new equals to 100. 100 is contained by Q. So just write Q. So this is 100. So when I write 100, so this will point to this. Then suppose we go for the forward traversing. So first we will be visit this node. So next it can at the previous part of this node contain 200. So next we visit this node. So at the previous part of this node contain 400. So next we visit this node. At the previous part of the new node contain 100. Then it will point to this node, and at the previous part of this node contain null. Okay. So this is about your forward traversing and backward traversing after inserting a node at any position. Then stop the procedure. Step 15, stop. Okay. So next we will see insert the node at the end of the list. Now we insert the new node at the end of the list. That means at this location we will be insert the new node. Okay. This is created as 400 and 30, null and null. Okay. So this is the steps for creating the new node. So here we create the new node. The address is held by the new pointer as per the previous two cases, and we will store the NO at the info part of the new, and we will be set the info pre and next part of the new node as null at the beginning. So as we are going to insert the node at the end of the list, so we must traverse the node from the beginning to end of the list. So for traversing we must execute a loop. Okay. So in step 5 set P equals to start P. So in step 6 we will be execute a loop from step 6 to 7 while next of P is not equals to null. Okay. Then set P equals to next of P. Okay. So assume the another pointer P which will be initially null. When I execute P equals to start, so it becomes 100. Okay. Then we will execute the loop for moving to the last node. So the condition is next of P is not equals to null. So P is 100. Next of P is not equals to null. Condition is true. Then we will store at the next part of P in P. So P becomes 200. Then again we will check the condition. The next part of 200 is not equals to null. Condition is true. Then again we will set P equals to next of P. So P becomes 300. Then again we will check the condition. If the next part of 300 is not equals to null, the condition is false. As the condition is false, then we will exit from step 6 to 7. Okay. Then in step 8, now we are at this location and we will link the new node with the last node of the list. That means we will be stored 400 at this location. That means at the last node of the list we will store 400. 400 will be stored at this location and 300 will be stored at the pre part of the new node. So for that I can write set next of P equals to new. So P is 300 and the next of P, that means this location, will store by new pointer value, that is 400. So this will point to this node. And next, for backward traversing, we will be write set pre of new equals to P. So it becomes 300 and for backward traversing. Okay. Then stop the procedure. Okay. So in this way we will insert the node at the end of the list. Okay. So this is all about your insertion procedure and algorithm for implementing the insertion procedure in double linked list. In next class we will be implement this algorithm into its function. Okay. Thank you. Keep watching.